We are continuing to talk about quadratics. So your EOC review for this week is about quadratics. So here is how they're used in the real world. So we have, I'm going to zoom in on little parts. So there are no negatives in the real world, right? If we're talking about negative distance, you can't think about distance as being negative. Distance is always absolute value. It's just how far away from zero is it. You can't have a negative distance. So if we have a zero on this side, and we are talking about a real world situation, then we could not use this as one of our zeros or solutions. So sometimes you'll have a negative and a positive zero. Sometimes you'll have 1 0. Sometimes you'll have no zeros. So this is how high off the ground did the object start. So let's say there's a scenario where someone's at the top of a building. He's going to throw a football up. He throws it up. It gets to the peak, and then it starts dropping down. So how high off the ground would be your y-intercept? That's what you would look for. The vertex is when is the object at max height. So it'd be, let's say, time. And then the y value of your vertex is how high does it get. That's your max height. And then the ball starts dropping. And it can only go down to the ground level. We're not saying that it's going to go below the ground level. So this is our positive 0. When does the object hit the ground? How long is the object in the air? So to figure out how long the object is in the air, you count how many increments this is. That would be how long the object is in the air. And when does the object hit the ground? That'd be your number of seconds, minutes, whatever it is. How high is the object after blank seconds? So plug in given seconds into the graph's equation. So how high is the object after 2 seconds? So if we count these all at 1, this is our time. X-axis is our time. So let's say 2 seconds. How high is the object? 1, 2, 3, 4, 5. So what is that? That'd be 1, 2, 3, 4, 5, 6. Around 6. So this is giving you an example of where you would see real world quadratics and how they relate to all the names that we have, or all the qualities that we have discovered: the 0, the y-intercept, the vertex. Okay, if we look at our formula chart that's in our journal, pull out your journal for me. Let's look at our formula chart. So for quadratic equations, let's see all the formulas we have looked at so far. We have standard form, so we have looked at that. Vertex form is what we are going to learn today. So let's look at that formula. A times x minus h squared plus k. Quadratic form we haven't learned yet, so we're going to skip over that. And axis of symmetry we have learned. So see how the vertex form has an A, an H, and a K. So we are going to use these letters and they will tell us about the quadratic function. This is similar to when we use that point slope form. So see how the point slope form has our y minus y1, m, x minus x1. There's a negative or a minus built into the formula. Same thing here. So we are going to look today about the h and the k values. So look back at your DIMB. Let's look at the vertex form. X equals a, x minus h squared plus k. we need to create a text box. Doesn't look like there's one for us right there. If it's written in this form, that's easy to find our vertex. Our vertex is just whatever the h value is and the k value. So it's h comma k. Let me make this bigger. Okay. So hk is our vertex. And it says blank is the axis of symmetry. So whenever we do our axis of symmetry, we use the x value of the vertex. So our axis of symmetry is x equals h. Because the axis of symmetry goes straight down our vertex and it cuts it in half and it's equal on both sides. It's the exact same shape. Okay, let's do this next one. All right, let's write our equation underneath it, the vertex form. Y equals a x minus h squared plus k. I'm going to use this on each one of them. Go ahead and write underneath each one of them. Or copy and paste it over. So if we look at this equation, we don't have an A, and all we're worried about right now is the vertex and the axis of symmetry. So see how this says plus 3? So what does that mean for this h value? What is the h value going to be? Why does it say plus 3? And the reason is because you have a negative in there. So minus a negative would become plus. So that means the h value is negative 3. And then the k value plus, because it's supposed to be plus, the k value would be negative 6. So I just replaced my formula with the values that would make it the exact same equation. So I would know which one's positive, which one's negative. And then the axis of symmetry is x equals whatever that h value is. So it is negative 3. There's no a value on this one, so it's just 1. We'll just do 1 times. Change that a value to a 1. All right, let's look at the next one. X minus 3 squared, and there's nothing there. So what's the h value? What would keep it the exact same? Just 3. What's the k value then? If there's no k value, what number would we use for that? 0. And then what's the a value? What could we replace that with? How could we make this the same but have a number there? Negative 1. So what do we know about this? How is this one going to be changed? How is it going to be like this? Like upward? What does that negative out front do? Or what do you think it does? It flips it. So it's going to be downward. All right, let's write the vertex. It's HK. So H is 3. Yep. 3. And then K, 0. Axis of symmetry is x equals whatever the h value is, so it's 3. All right, go ahead and do the next one. Okay, so let's go ahead and look at it. What would the h value be? What's the k value? So what is our vertex? No, because our formula is plus k. So on this one, it was minus 6, but our formula says plus something. So we had to put plus something, which would be negative 6. So this would be 4, 7. And then our axis of symmetry, x equals 4. What is our a value on this one? 1. All right, this one. So the 3 is just a constant, so we can go ahead and put that here. How could we have x squared and have this x minus h? What do you think h would be? 0. Because that would just come out to x squared. So then what's your a value? Negative 2. This would simplify because you would just do x squared negative 2x squared. So then the vertex, 0, 3. And the axis of symmetry, x equals 0. Get out a calculator. And let's look at all of these because I want you to practice and hopefully remember how to find the vertex so that we can check it with the calculator. Let me slide this over. Y equals parentheses x plus 3 squared minus 6. Okay, do you remember how to find the vertex? We need to go through those steps again. So are we going to have a minimum or a maximum on this? What kind of value? See our vertex? It's where it changes direction. Is that going to be a minimum of the function or a maximum? Minimum. So how do we get to that menu where minimum is? Where is minimum? Second trace, yep, which is our calculate. Going to go to minimum. We need to go to the left side. So here is where our vertex is, right? Get your cursor to where the vertex is, and then go to the left of where that vertex is. So I'm going to go over here. That's to the left of my vertex. I know the vertex is right there. Push enter. Now go to the right of the vertex. Push enter. Guess, push enter. Negative 2.9999 and negative 6. Which isn't that the same as saying negative 3 and negative 6? Okay, so I want you to go through and do these just like that, because I want you to practice finding your vertex. Actually, I'm going to put in the original, so negative parentheses x minus 3 squared. I'm going to put it in just like they gave it to us. Second trace, minimum. Find where that minimum is. No, we're not doing minimum on this one, are we? I did the wrong thing. We need to do maximum, because that's our maximum value. So we need to go to the left side of the maximum, then go to the right side of the maximum. Guess, enter. What about this value? What would I estimate that to be? Negative 2.15 e to the negative 12.
0.
Yeah, 0, exactly. So 3, 0. Let's go to the next one. X minus 4 squared plus 7. So whenever we have this one, we can hardly see it. We could zoom out if we wanted, but really we just want to know that value. Is that a minimum or a maximum? Minimum. And then you're going to have to find the cursor. Okay, there it is. I went to the right to find it, and it kind of tells you where it's at, so you can try to find it. Push enter, then go to the right. Enter, enter. 3.44 or 3.9999, and then 7, so 4, 7. And on this one, this is a maximum. Go to the left of where that maximum value is. Go to the right of where that maximum value is. Guess, enter. So this negative 1.279 e to the negative 6, that rounds to 0, and then 3. All right, let's go to the next two problems. Y equals x plus 2 squared minus 3. So our axis of symmetry, we got to create some text boxes here. Do it like that. And let's see, 24. Gonna make it blue again. So our axis of symmetry. Well, let's do our vertex first. HK. This says plus 2. So what would the H value be? Negative 2. And the K value is negative 3. Make these bold. Now I'll go back up to the axis of symmetry. The axis of symmetry is the x value of our vertex. So x equals negative 2. Okay, our domain. What's our domain going to be? Should we go ahead and graph it? Yeah, let's graph it. Where have we graphed them before? So that we can, we've graphed them over here. I need that parabola, because I guess we don't have one on this, do we? Do we have one out to the side? Nope. Okay. So I'm going to copy it from the other slide and do 2 of them. And then I need some points too in my axis of symmetry. Okay, so now I'm ready. Now that I have those tools to use. Okay, axis symmetry is x equals -2. Are you all ready? Or you'll need a little bit more time to get those things. Y'all good? Got it? Okay, so x equals -2 would be a vertical line on -2. And then -2, -3 is our vertex. I don't like how big that point is. There we go. So in order to graph it, we need points. So we are going to put points in this table value. Notice how on the table value, they put a circle in the middle. The point that's going to be in the middle of the table is going to be our vertex. So -2, -3. And what we want for a quadratic is we have a middle point, and then we go up 1, 2 to find 2 more points, and then just reflect those. So the first point that we put on our table, we put it in the middle of the table, and you have 2 on one side and 2 on the other. That way you can get a good idea of what your quadratic function looks like. So we are going to go up. So -2, the next one would be -1. And then the next one, let's see, would be 0. If you're looking at your x's. So then we look at the other side. So we're going to go down. So that would be -3 and -4. So the vertex goes in the middle. We know the x and y value for that. And then to find points on both sides of the vertex, we go 2 to the right. So from -2, we go to -1 and then 0. And then 2 to the left, that means it's getting to be a smaller x value. So that's why we get the -3 and -4. Okay, so we need to find the value. So we could use our graph, our calculator. We could plug in numbers. What do y'all want to do? It would be something that you would actually do while you're taking a test over this. Calculator, let's do it. So we'll look at the table and we'll fill in the numbers. So we know that the vertex is -2, -3. So then -1 is with -2 and 0 is with 1. So -1 is with -2 and 0 is with 1. And then -4, what does that match with? +1. And then -3, -2. And we know this quadratic is going to go upward because we have a positive number out here. It'd be a +1. So let's get a few more points. There we go. -3, -2, -4, +1. -1, -2. And we know they reflect across that x-axis. And then 0, 1. Once you plot the points, and you can put your parabola over the top. Try to extend it out. See. Something like that. And then the domain is the x values. For quadratics, what is the domain?
Three. I mean,
It's going to continue out, on and on forever, right? The x values continue on and on forever, so it's all real numbers. But the range, what do the y values not go below? -3. So is the y values greater than or equal to, or less than or equal to -3?
less than.
Greater than, yeah. And it's or equal to, so make sure to use the or equal to. Okay, let's go ahead and do the next one. We need to find our axis of symmetry. Which I usually like to do the vertex first. But it's our HK. But on this one, how would this be written? It's A x minus h squared plus k. So what is the k value?
-5.
-5. Okay. What's the h value?
0.
0. And what's the a value?
3.
Okay, so now we know what the vertex is.
It is 0.
0, -5. What's our axis of symmetry?
0.
Yeah. Let's go ahead and do this. So we have 0. What would go on one side of the 0 to go forward? What would the x value be? What would I need to put over here for my table of values? If I have 0 in the middle,
-5.
down there, so let's see, -5. What other values will I look for? I go from the vertex, I go up. So I go 1, and 2. And then backwards, -1, -2. Use your table of values on your calculator to go ahead and find those, and then start graphing it. All right, make sure you have this completed as well as slide 13.